on materials. All right. You're going to click on materials. You're going to click on the guided notes. All right. And then top right corner to open in Notability. Okay. Open in Notability. Open in Notability. Okay. Add create new note. I don't know why it defaults to something else, but create new note. Done. All right. Takaya, because this is all new, feel free to jump in. And, you know, another student could probably jump in and answer your question probably better even than I could, okay? But don't hesitate.
Okay.
All right. Let me get my pen. All right. Oh, now this is still in Google Doc. Let's go to Notability. All right. That's my last document. All right, so guided notes. Okay, here we go. All right, so it says, how can the exponential expression 3 to the 6 over 5 be written as a radical expression? Okay, let's talk about a couple things. All right, an exponential form. Guys, a lot of times we're going to ignore the actual question here. We're just going to use the math. Okay, you can write a number in two different ways, exponential form and radical form. Okay, 3 to the 6 over 5. Okay, all right, 3 is the base. So base to the power over root. Okay, so the radical form of that, I bet you I can tell you guys something that maybe you've never even heard of before. Tell me if you've heard of this before. Somebody jump in without, turn your mic off and jump in. What's the square root of 4?
2.
Right, 2. Okay.
I'm smart.
Did you know that a square root has an imaginary 2 right there? Who's seen that before? Jump in the chat and be like, no or yes. Jump in the chat.
No, sir.
All right. Because it's not always a 2.
Yes.
How about a third? How about the third root of 8? Who's seen third root? All right. The third root of 8 is 2. All right. Now here's what that means. The third root means 2 times 2 times 2 is 8. 3 2s. 2 times 2 is 4. 4 times 2 is 8. So 3 2s make 8. Okay. So the third root of 8 is 2. So it's common that we talk about square root, but it doesn't have to be square root. The third root of 27. Third root of 27. 3 times 3 is 9. 9 times 3, 27. So 3. Because 3 times 3 times 3. Okay? That number could be anything. Okay? All right, and you know what an exponent is. So an exponent's a power. Okay? Now, so this exponential can be written as a radical. It can be written as, okay, the base goes there. Okay? The root goes here, like the square root or the third root. So that's 5. And then the power is on top, it goes 6. Okay? So, oh, what the heck is that? What do I do to get rid of that?
Press the magnifying glass, yeah.
Thank you. All right. So base, power up here, outside, top right. And then in the hook, root. Okay? So what we're going to practice today is how to go back and forth. How to go from exponential to radical and how to go from radical to exponential. So if you just power over roots, power over roots, power over roots. And when you go over here, just remember that the power is always the exponent. Okay? So if you remember power over root, that'll give you that order over here. Okay? And then, well, which one's the power here? Well, the exponent is the power. So you know where an exponent goes. You've heard that word 100 times. Okay? All right. So let's change 3 to the 2/7. And then let's change 7, the third root of 7 to the 4th power. Okay. Let's call this example 1 and example 2. Okay. Okay. All right. So again, base to the power over root. Okay. So the base is 3. The radical sign goes around it. Notice I didn't call it a square root sign. I called it a radical sign. It's only a square root sign if there's a 2 there. All right. But that's not a 2. The 7 goes there and the 2 goes there. Okay. And now 7 to the power over root. All right. Look difficult?
Oh,
All right. Can you guys do 2 for me on your own? And then I'll give you the answers in a second just to check. All right. A to the 5/11ths. And then the 6th root of H to the 11th power. All right. Can you guys do those on your paper?
can you scroll up a little bit? I just want to see if I wrote it correctly.
These?
All right, yeah. Now I'm good. Yeah, thanks.
Okay, sure. Yep. Guys, feel free, jump in like that. That's if we were in school, I am not that teacher that's like, please raise your hand and wait. All right. Like, you know, don't be mean, but just jump in and say, hey, can you go back a second?
Can you go back up a bit? I was almost done with it.
Uh-huh. Sure.
Thanks.
Can you go back down?
I was trying. I think it froze.
Oh, yeah.
There you go. All right. The 11th root of A to the 5th power. Okay. And then H to the 11/6. Okay. All right. All right. Now let's talk about calculator for a second. All right. Guys, the iPhone calculator is not good. Okay. It's not that good for things like a fraction and these different exponents. It does work, but I don't know that it's easy to use. Okay. So let's just talk about a couple things. You want to get a calculator with a nice fraction button. Okay. If you notice over here, the nice fraction button. All right. There you go. Okay. But yeah, other than that, guys, I'm not going to be like, this is the calculator you should use. Doesn't matter. Okay. All right. Let's just practice a couple things. 3 to the 5/3. And then let's do 3 to the 3/5. Okay. We're going to put these in our calculator. All right. Here's what I want to point out to you guys. All right. This first one, 3 to the 5/3. If the top is bigger, you're going to make the answer is going to be bigger. Okay. The answer is going to be bigger. 3 to the 5/3. Okay. All right, now that's some goofy, hit that approximate button. All right, we made it bigger. We made it 6.24. This thing says rounded to nearest 10,000 or nearest thousandth, 10/100th thousandth. Okay. All right, so we made a 3 into a 6. We made the number bigger. Okay. But now when we raise 3 to the when we raise 3 to the 3/5, what happens? We make the number smaller. Okay. All right, that's not a coincidence. That's going to happen all the time. Okay. There is a button on here where you can do that, this type of thing, to put that in your calculator. But here, this might be easier to change this to an exponent and then put it in your calculator. It's probably easier to do that. Okay. But we just practiced that twice, so we don't need to practice it again. All right. But is that answer 4 to the 10/8? Is that going to get bigger than 4 or less than 4? It's going to get bigger. Okay. All right. Example 4, a word problem. You know how these go with this integrated
Could you
stuff?
go back a little bit?
What's that, Zed?
Could you go back a little bit? I wouldn't finish.
I tried. It's it's slow.
All right.
There you go. Okay. All right. So this last word problem. A town's population is decreasing. The population in the year 2000 was 4,000, and the population T years after 2000 can be found by using the function. All right. So they give us a function. So what a function means is you put a number in and you get a number out. Okay. It's all about an input and an output. Okay. All right, so that's the function. It says, what was the town's approximate population 2.5 years after 2000? All right, so f of t, that's how you read that. Function of time, f of t, function of time equals 4,000 times 0.96 to the t. All right, somebody put themselves out there. Turn your microphone on. First of all, what does t stand for?
Time.
In what? You're absolutely right, Aldo. In what, though?
Years.
In years. Perfect. Okay. So really, the point of the question is to type in, we're just going to plug in 2.5 into the t. So we're going to take our calculator, put that in, and then get an answer, right? That's the point of the question. All right. What I want to show you is, look at this 0.96. Is the population getting bigger or smaller?
Smaller.
Getting smaller. What would it look like if it was getting bigger?
A hole.
Right, it would be a whole. It would be 1, right? So like 100%. More than 100% is grow. Less than 100% is decay. So it's taking away. It's a decrease. All right. If your boss was like, "Hey, I'll give you 100% of your salary next year as this year," well, you didn't lose any money, but you didn't get a raise. 100% of your salary is what it is, right? What if I'm like, I'll give you 100% of your points? Well, no kidding, right? If I'm like, I'll give you 80% of your points, you're like, whoa, 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 why am I losing? Okay, so 96 is less than 100, so it's going down, okay? All right, so anyway, all you have to do is 4,000.96 to the 2.5, okay? So let's bring that calculator back. All right. 4,000 times 0.96 to the 2.5. Guys, the iPhone calculator, it will do what I just did, but it like doesn't have a nice exponent button. You don't get to see it. The thing to me is what's a good calculator and what's a bad calculator? Do you get to see what you write? If you get to see it, then I like it. Okay. All right, hit enter. All right. 3611.919. All right. Somebody jump in. Put yourself out there. All right. Put yourself out there. Be confident. What is that? It's so slow. I have the number written down, but it's slow. Okay. Slow. There you go. All right. What does that number mean? 3,611 what? Somebody jump in the chat or the microphone. What, Gabe?
Population.
Yeah. So population means what? How many what?
People.
People. Exactly. Right. If I give you a word question, I want a word answer. So it's 3,611.9 people. Now, have you ever met 0.9 of a people? All right. So should we?
No.
How do we round this then? To a decimal or to a whole?
To a whole.
Right, exactly, because there's no 0.9 of a person, right? So because it's 0.9, we round up. Okay? How's that sound?
Okay.
All right, so now, I'll leave this screen up because I know some people are probably writing, but right now, not later, not homework, right now, send this back to me and put it in Google Classroom under the same post about the notes, not the homework one, the notes, okay? I'll leave this up for a minute so because people are writing and catching up and whatever, all right? But send this back, okay? Takaya, I know you are new overall to Bremen. So, you know, this is like without being in person, it's hard to talk about like, you know, like, do you know somebody or does somebody live around you? Do you know anybody in here?
Yeah, I went to Central Park before, so I'm familiar with a few kids.
Oh, perfect. What I was going to say is like, if there's somebody in here, you know, that can help you, you know, like I said, I overwhelmed you at the beginning of the period with this and this and this, you know, it sounds like you're on top of this, but like later on this evening, whatever, if you could just text like your friend or whatever, you can message me in that group thing or individually on that Google Hangout. You just type in Chihoin and it pops up and it's like sending a text message. Okay.
Mm-hmm.
All right. Now, guys, I put on that Google Hangout post about, you know, like it's school appropriate and et cetera. You can though send a picture. And the only reason why I would think you would send a picture is if like you could, you know, send a picture of like your work on the screen and, hey, this is where I'm stuck. Right. So, you know, just keep in mind that this is for school and, you know, we'll get PPS involved if we ever needed to, but okay. But yeah, all right, I'm going to hit stop record. Okay.